modern refrigeration and air conditioning. Chapter 33, Commercial Air Conditioning Systems. Objectives. Summarize the features of rooftop units and package outdoor air conditioning units. Identify the types of controls commonly used in commercial air conditioning systems. Explain how variable refrigeration flow is incorporated into commercial air conditioning applications. Explain the basic operations of a chiller system. Compare the different types of compressors that can be used in a chiller system. Explain the basic function and operation of a cooling tower. Understand the operation and purpose of different types of water valves used in water-cooled condensers and cooling towers in commercial air conditioning systems. Rooftop units, RTUs, complete package HVAC system, many uses forced air distribution, cooling and heating or both, designed specifically for rooftop installation, factory assembled and tested. These units are probably the majority of what you'll see when you go onto a commercial roof. Not necessarily the style, but this is what we have on the roof of the school. These systems work just like any air conditioning system. There's a section that does the condensing and a section that does the evaporating. Normally there are multiple fans and multiple compressors, up to 6 per unit. And most of the time they're belt driven, and we'll go more into that later. RTUs connected to duct system. In most cases, rooftop units are a downflow system. That means it sits on a curb and the ductwork is connected to that curb, usually between 4 and 6 inches high. And the ductwork is built underneath this roof of the building. And you can see where we have warm air returns and the cool air outlet in the summer or the warm air in the winter. Here's a package outdoor air conditioning unit. If you think about your refrigeration, it's pretty much all the same. There's not anything different in the refrigeration system for this unit and the unit you have in your home. This is mainly a commercial system. This unit is what's not a downflow. This is a side draft unit. And there's some odd items on here that you won't see normally in a home system, like the humidifier in the top left-hand section. So this unit actually spins water droplets off that wheel and gets picked up by the supply air and takes it through the ductwork into the living space to add a little bit of humidification. Now you won't find that in Florida because we have plenty of humidity, but remember, air conditioning takes out humidity, so depending on how well that unit works and how long it runs, you could take a lot of humidity out of the air. But normally you'll find these out in the West in desert climates where there's, during the summer, you might be down to 3% humidity. In most cases, you need 35 to 55% to keep your body healthy and to keep dust from forming on everything, keep allergens down. There's a few other little items on here. This is a gas. You can see the burner on the bottom. So it's a gas burner. But normally most of it is all the same, as you would see in a residential system. Rooftop unit installation and considerations. Some of these are fairly obvious. The roof must be strong enough to support the weight of this unit. A, say, 20-ton air conditioning heating system could weigh 3,000 to 4,000 pounds. Most roofs Depends where you're at in the country. If you're in a part of the country that has a lot of snow, roofs are already meant to hold thousands and thousands of pounds of snow. So that's not an issue usually. But if you're taking a building like a metal shed building, something that maybe does manufacturing, you're taking a unit from the ground and want to put it up on the roof, that has to be a consideration to make sure it will hold that weight. Roof openings may develop leaks, so this is something that should be done by a professional roofer. Um, you need someone to take the curb, which is the box that sits underneath the unit. Again, it's 4 to 6 inches tall, and it's ductwork. It fits the ductwork of the unit that you're setting on top of it, and it's got to be sealed on the roof. Um, this has got to be able to worked on in all kinds of weather. You have to think about some things that we're not covering, and I don't think they cover on this. You're going to have some sort of railing around it, some sort of platform, especially if it's on a slant, so people can get up there and work on it. Imagine needing to change air conditioning, condensing fan motor on the top of this. These units are already 4 to 6 feet tall, and if it's built on a roof that's angle, so it's going to be level on the front, that might be 8-10 feet off the ground. It's not a good place to put a A-frame ladder up there with it. So it's got to have some sort of scaffolding or built onto the system so you can get up on the roof, some sort of walkway. Again, it says technician must carry tools and supplies. So another thing you have to think about, is there an access to get up on that unit, up on that roof? If there's not, then you need to make this aware if it's something that you're dealing with. Some of these units are 30, 40 feet up in the air on top of a roof. You need to be able to get up there safely. Rooftop unit heating is just like a standard unit that either is on the ground or a package system or a split system. There's going to be gas-fired furnaces, which is more common on the coastal states because we find a lot of natural gas in that area. Oil-fired furnaces, heat pumps, and electric heat. Very few businesses, depends on what kind of business, but very few businesses need a lot of heat in the winter, even when it's cold. Now, if you're up in the Northeast where, it can get below 30 degrees, I mean, below 0 degrees, it's something that you need to think about when sizing a unit. But most companies where they work, if it's an office building, don't use a lot of heat because with computers and employees and lights and all those things that make up an office, usually air conditioning will run most of the winter as well. Streams of airflow through a rooftop unit. It gives you a little idea of how it happens. You can see this is sitting on a roof, and the return air goes up, gets sucked through an evap coil, and can also, the conditioned air gets pushed through the section on the right. Sometimes you have a box that just does the airflow and moves into the air conditioning system, but just gives you a little idea how it works. Also, they mention on this slide is fresh air and exhaust air. Some units in buildings that are very tightly sealed, there's got to get air inside it. And if it's not a store where the door is constantly open, it's more of an office building, the door doesn't have big enough air return to make the smell and the used carbon dioxide to get out. So usually they use the fresh air intake and exhaust air. And I think this system, it doesn't show that real well, but we'll go through it a little bit more. The unit we have on the roof does have a fresh air intake. That's that upper blue section, and you can see the lower exhaust system will open up, and these are usually done electronically. They'll open up and exhaust some air sometimes. Air side economizers. In a nutshell, what an economizer does, and to make it easier for you to understand, think of a building in a bank building, let's say 2 stories, and it's in a place where it's 50 or 60 degrees in the winter, somewhere like Florida or somewhere a little farther north. There's really no need for heat. And when you're working in that office building, when you have a whole bunch of cubicles and there's a person, a computer, uh, lights overhead, it gets warm in there. So even though it's 60 or 50 or maybe even 40 degrees outside, that inside that office will get very stuffy. So what you would do with an economizer is, instead of needing to, let's say it's 80 degrees in the building, even though it's cold outside, instead of turning on the air conditioning, the system shuts the air conditioning when the thermostat calls for cooling. There's a thermostat outside at the economizer that tells what the outside air. If the outside air is 60, instead of turning on the air conditioner, it opens a vent. It sucks outside air in that is 60 degrees up off the roof and dumps it into the building. So instead of using the power of the large compressors in a commercial unit, it just turns on the indoor fan and circulates the air from outside to the inside. Empathy control. This is a psychometric chart. I'm not going to get too far into this, and you're not going to see any questions on your test about this. But a psychometric chart is used to figure out how air works, humidity works, and temperatures work on paper, so you know how adjustments you need to make in the system. And we'll go more into depth in the future of these, but they're very simple. You can look them up in your book. It's much easier to look at the pictures in the book than on this slide. But it's no more than matching up lines to find a point on a chart and get the information you need. For example, if you know what the relative humidity is and the temperature is, you can get a dew point, which is used to figure out charging. Or if you know the dew point, you can figure out what the relative humidity outside is. But look into that in your book. Again, I don't think there's going to be any questions for you on this, but it's a good thing to see, because some units that you will install will have a psychometric chart to tell you how to charge this unit using either subcool or superheat and where that should fall. Comfort cooling controls, operation controls or operating controls, thermostat, humidistat, pressure switches, limit controls, pressure, temperature, motor values, and anti-icing controls, sequential controls, adjusting operation for demand and performance, multiple compressors, condenser fan motors, and other devices, pneumatic controls, controls devices using air pressure. So in some of the things that these terms you would know, for example, the thermostat. Well, the humidistat is some way to control the humidity. Again, in the South, we get used to it always feeling sticky. What your air conditioning can do, especially in a business, and you might need to control, you might be doing a book publisher. You might be somewhere that manufactures paper. You have to limit the humidity that you can have in the air, but you don't want all of it gone. So it either can add humidity or take humidity out of the air to balance the system. So that's a control they use. And the pressure switches are primarily for air movement and humidity. The limit controls, if there's low pressure systems and high pressure controls. The temperature controls, something that can be put in the return air duct. It tells by the temperature that the air is leaving or coming into that duct. Do you need to add or lower the amount of refrigerant going into the system? Motor values. There's the Carrier Affinity system that has a motor values control. So it knows if that filter is dirty because that motor starts using more amps than it did when the system was new. And it can figure out how many amps is drawn on that motor by motor value control. The de-icing controls, that's as simple as a defrost timer on a heat pump in a residential setting. Installing rooftop units. Riggers are mainly crane operators. They handle the installation and removal and replacement of the unit. Usually there's a technician there as well, air conditioning professionals, but they handle the movement of the unit while it's being set or removed. Install methods are used to provide leak-proof roof connections, and there's a diagram of what one should look like. Gas and electric and oil connections must comply with local codes. Remember, the gas, electric, and water drains are going to have to go through the roof of the building to get to wherever they need to go. So those things have to be sealed up and have to meet code. Here's some requirements for rooftop unit installation. You can read over these. They're a lot easier to see in your book, like the distance from the curb to the ductwork, how it is measured, things like that. Flexible connections on the supply on that bottom left-hand side. If you don't, you get a lot of vibration from the bigger units. So you need some of these things built onto this. Ladder safety, portable ladders, placement based on the base of the ladder is firmly grounded, leans up against a building 1 foot out for every 4 foot of rise. Extend ladder 3 inches above the roof edge. Use both hands on a ladder. Do not use portable ladders in high wind. Do not attempt to carry equipment or supplies up and down the ladder. Usually use some sort of lift or just use a rope that you pull it up once you're on the roof. Variable refrigerant flow systems, multi-zone temperature control, maintain constant temperatures for varying heat loads, vertical piping limited to 150 feet. And they're talking anything. For example, drainage pipes, water lines leading up for cooling, or gas lines, they're limited because of the roof movement. Air handlers are still needed for ventilation, air cleaning, and humidifying. VFRs for large commercial buildings. Gives you a little breakdown of how it works. Chillers. Used a loop of chilled water instead of forced air to cool a condensing space. A little bit about a chiller. It's a very specific trade in the HVACR industry. They are very dangerous. They work on very high pressures. They use things like ammonia gas rather than using a refrigerant like 410A. So, and some of the refrigerants they use, like ammonia, can be explosive at certain pressures and temperatures. So it's a very serious job. But a chiller, instead of using, it's much more economical to heat and cool water that runs to coils within a large building, something like the Empire State Building. Every 10th floor has chilling systems on them, so that they don't do cool more than 10 floors at a time. This is traditional for refrigeration. Cools the water. Water circulates through the building to cool occupied space. Low energy consumption during part load or full load operations. A chiller refrigeration systems can either be compression or absorption. Mostly used for large installations, commercial or industrial. Refrigerants in compression chillers. Secondary refrigerant absorbs heat from conditioned space, usually water, but can be a cooled brine or glycol solution. Primary refrigerant absorbs the heat from the secondary refrigerant and rejects the heat from the system. They use R22, 134A, 410A, and 407C. Those are very common refrigerants in any commercial refrigeration or air conditioning system. Caution. Refrigerant systems using 407C or R410A operate on a higher pressure than R22. 407C and R410A should only be used in systems designed specifically for their use. Components of compression chillers, same as standard air conditioners: compressor, condenser, metering device, and evaporators. Components are larger and accommodate increased amount of refrigerant, industrial, and large commercial applications. Here's a diagram of a compression chiller. It's going to have pretty much the same components as an air conditioning system does, but it's not using air to cool and heat, it's using water. And you'll see more diagrams of these in your book. Heat rejection from a chiller system. The method depends on the building, local codes, cost of operation, and maintenance. Options: air-cooled condenser, water-cooled condenser, water-cooled condenser connected to a cooling tower. Here's a water-cooled circuit, a condenser water-cooled circuit. This is like any other air conditioning system. It just uses water rather than air. A few things that I'll bring out that are unlike this system, there is a cooling tower that uses a drip system at the top. At the bottom right-hand side of that large piece, you'll see that blue section that has the yellow float ball in it, and this is a makeup water. So anytime the system starts losing water from dehydration, from air evaporation, it needs to be replaced, and this is an automatic system that keeps that water reservoir full for cooling the system. Types of compression chillers. High pressure chillers operate under high pressure, used primarily for commercial and industrial process cooling. Low pressure chillers, centrifugal chillers charged with R123, operate under low atmospheric pressures. Auxiliary components for chillers. Purge units removes non-condensables from the refrigerant, kind of like a filter dryer. Preserves systems efficiency and prevents damage. Secondary emissions collection device captures refrigerant that escapes during purging. These systems, sometimes to keep the pressure down on them, they'll actually purge air out, purge refrigerant out of the system. And that's what these secondary emission collection devices do. They recover that refrigerant. Chiller compressors, the types are reciprocating, like we use in normal air conditioning. They'll just be much larger, and usually they're not hermetic. They're able to be rebuilt. Scroll compressors, screw compressors, and centrifugal compressors. Types are used depending on the tons of the air conditioning needed. Multiple compressors are piped in parallel for capacity control. Reciprocating compressor for chillers, used in systems ranging from 10 to 150 tons. Hermetic or semi-hermetic. Advantages are simple controls, low cost, efficiency, and low capacity applications. It's an important thing. They don't work, reciprocating doesn't do high capacity. They do very low capacity. Disadvantages: greater maintenance required, multiple compressors, usually use capacity control, and backup operations for breakdowns. Cylinder unloading. Reduces overall system capacity, done in steps to reduce compressors' purging capacity. Unloading methods: blocking intake passages, holding suction valve open, reduces electrical power and consumption, measures few amps. So this is the concept of riding a bicycle from a stop uphill. Imagine with doing it on a constant basis. How this does is this lowers pressure by letting some of the cylinder, the backup pressure, to be unloaded onto the low side. That way it's not so hard for the compressor to do its job. Scroll compressors for chillers use two matching spiral scrolls like you've seen in chapters before, and also that we have one in class that you can take apart. They're welded hermetic units, so they're not rebuildable. This makes them less likely to want to be used. The bigger units can be repaired in all other types except for this type. It's used in range from 10 to 25 tons. Capacity controls cylinder off and on multiple compressors. Screw compressors for chillers up to 750 tons. These are probably the biggest. I'm not sure if there's anything bigger than this, but the benefits: they have high output capacity, few moving parts, can pump some liquids without damage, flexibility in piping, capacity controls with slide valves, usually from 10 to 100% fully loaded. So this unit can slow down, and that's what makes them so economical, and pump a lesser amount just by a pressure switch. Centrifugal compressed chillers, cost effective for large loads over 150 tons. Few moving parts, uses low pressure refrigerant, uses centrifugal force for compression, gearbox and impellers, use of chiller economizers improves efficiency. Lubrication and oil capacity control. Oil pumps and driven by separate motors that lubricate centrifugal compressors. What's good about this is you could start the oil pump before the compressor starts. That way it's pre-lubed, so you don't take a chance of it starting up dry like the car that you have that you drive. There's no oil movement until the engine is started, which gives you a chance if a car is sitting for a while, it could have lost a lot of the oil that lubricates the inside of the engine. Sealed systems, oil do not mix with refrigerant. Heater and oil sump reduces refrigerant migration. Capacity controls by adjusting guides, vanes, and center of impeller eye. Control amount of refrigerant allowed to enter the compressor. Creates rotational flow in refrigerant to match impeller rotation. Here's a diagram of a centrifugal compressor chiller system. Cooling tower, a structure that removes heat from an HVAC-R system. Cooling water is used for evaporation. Some water evaporates to cool the remaining water. Cooler water circulates through the condenser. Makeup water replaces the evaporative water. And again, on this picture, just to show you again, there's this little bottom right-hand corner blue box that has the yellow float and valve in it. That's something that it constantly is adding water. Whenever the water drains down, it adds more. So it's an automatic fill system. Cooling tower is continued. Efficiency depends on airflow, temperature, and relative humidity. Best performance, cool and dry weather. Types of water loss, evaporative, drift, and blowdown. And it also has a chance, they also have makeup water, which is that section I've showed you before. Cooling tower construction, wet deck, maximizes water and air contact. Contains fill to increase water-air contact. Water distribution pressure, water systems, gravity flow basin. Cooling tower water circuits, open loop cooling tower. Water from the condenser flows directly over fill. Condenser and cooling tower share the same water. Some water lost to evaporation, drafts, and draining. Closed loop cooling tower, heat exchanger between the condenser and the cooling tower, two separate water circuits on a closed loop system. Cooling tower airflow design, counter cooling tower, air and water flow in opposite directions. Cross flow cooling tower, air flows across the wet deck from side to side, water drops down from above. Cooling tower draft options. Natural draft cooling tower relies on wind or natural convection. Induction draft cooling tower, fan and air outlet draws air into the tower across wet deck and out the other side. And then there's a forced air cooling tower. Fan at air inlet blows air into the cooling tower. These are terms you'll need to know from this chapter. Here's a code alert because of the vapor fumes from cooling tower can drift into the wind and affect other areas. The positioning of cooling towers is especially strict, regulated by local building code. Codes also dictate proper anchorage and support of the towers and proper water supply and draining pipe to the tower. Cooling tower operational considerations: effective humidity. Higher humidity reduces the rate of evaporation. Lower humidity raises the rate of evaporation. Let me read that again to you. It's really important. Higher humidity reduces the rate of evaporation. Lower humidity raises the rate of evaporation. Freezing in seasonal cold climates, use basin heater, and we're talking about the water basin. Use insulation or heat tracing on water piping. This is going to be something that you'll have some sort of heat going to it, and it could be just insulation, or it could be wrapped by a wire that stays warm to keep the water from freezing. Chemicals added to the water, like an antifreeze. Cooling tower operational considerations: capacity controls, fan cycling, multi-speed motors, VRF drives, adjusted tower louvers, bypass hot water using thermostatic mixing valve. Water valves regulate water flow throughout the water-cooled condenser, usually installed between the water supply and condenser water inlet. Types are electric, pressure, or thermostatic. For this, you would either have an electric sensor that would tell you when to add water. Pressure, being it would open up under certain pressures, and thermostatic is taking the temperature of the water, opening at that point. Electric water valves, solenoid water valves, either fully open or fully closed. No variable flow control on a solenoid water valve. Motor water valve opens and closes valve using a motor, capacities from 1/2 inch to 4-inch pipes. Pressure water valves regulate flow based on high side pressures. High side pressures open wider or more flow. Lower pressure opens less for reduced flow. Provides variable controls. Springs can be adjusted to change valve response. Thermostatic water valves work just like a thermostatic valve on a mixing device, kind of like a TXV. Regulates the water flow based on the temperature of the water leaving the condenser. Warmer water causes the valve to open more. Cooler water causes the valve to open less. Operation is intended to ensure that sufficient heating is being removed. This is your last slide, and there will be a video after this that you need to watch.